Hello dear students. So let us discuss about the tricarboxylic acids. So tricarboxylic acids are those organic compounds which contains three carboxylic functional groups. Okay. For example here, see the citric acid. So citric acid is an example of tricarboxylic acid. So here you can see its structure. So it has three COOH groups. So citric acid is a tricarboxylic acid. Okay. So its a common name is citric acid. Commonly it is called as citric acid. Its IUPAC name is 2-hydroxyl propane 1, 2, 3 tricarboxylic acid. So similarly, you can see here one more example. So that is a tricarboxylic acid. Tricarboxylic acid. Okay. So its IUPAC name is propane 1, 2, 3 tricarboxylic acid. So one more example here, aconitic acid. So it is also an example of tricarboxylic acid. So its IUPAC name is 1 propene 1, 2, 3 tricarboxylic acid. So next let us see the properties of this citric acid. So the chemical properties of the citric acid. Okay. So the citric acid. So it is example for the tricarboxylic acid. So let us see the properties of the citric acid. So first let us discuss about the action of heat. Okay. So citric acid when it is heated to 150 degrees Celsius. 150 degrees Celsius. So this citric acid will going to form aconitic acid. Aco- Aconitic acid. So let us write its reaction. So let us write the structure of the citric acid. So it contains three COOH groups along with one hydroxyl group. Okay, so this is citric acid. Citric acid. So when this citric acid is heated to about 150 degree Celsius, so the citric acid will going to form aconitic acid. COOH. So this is aconitic acid. Okay. So next we shall see one more example. So when the citric acid is heated with fuming sulfuric acid. Fuming sulfuric acid. So the citric acid will going to form acetone dicarboxylic acid. Acetone dicarboxylic acid. Okay. So let us see its reaction. So first let us write the formula of citric acid. So this is citric acid. So when citric acid is heated with the fuming sulfuric acid, it forms acetone dicarboxylic acid. acetone decarboxylic acid. Acetone decarboxylic acid. Okay, so let us discuss about the second type of properties. So under that, so let us discuss about the reduction with HI. Reduction with HI. So when citric acid is refluxed, okay, so refluxed with hydroiodic acid, that is HI, hydroiodic acid, it forms a tricarboxylic acid. Tricarboxylic acid. Okay, so let us write its equation. Citric acid okay, so citric acid when refluxed with hydroiodic acid, that is HI, reflux, so it will go into form tricarboxylic acid. Yes, H2O and I2. Okay, so this is tricarboxylic acid. Okay, so next after this, next we shall discuss about the polycarboxylic acids. Okay, polycarboxylic acids. Polycarboxylic acids. So polycarboxylic acids are those organic compounds which contains more than 3 COOH groups. 3 carboxyl functional groups are called as the polycarboxylic acids. So when the OH group of the carboxylic group, so that is when the OH group of this carboxylic group is replaced by the groups like Cl or 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 OCOR or NH2, etc. So they are called as the acid derivatives. Okay, they are called as the acid derivatives or the derivatives of carboxylic acids. Okay, so all these acid derivatives, okay, upon hydrolysis gives the parent carboxylic acids. Okay, so let us discuss about the different series of acid derivatives. So under that, first let us discuss about the acid chlorides. Acid chlorides. Okay, so acid chlorides are nothing but the derivatives of carboxylic acids where the OH group of the carboxylic acid, so this OH group of the carboxylic acid has been replaced by the chloro group, so that is Cl group, are called as the acid chlorides. Okay, so the general formula of the acid chlorides can be written as RCO Cl. Okay, so where R may be an hydrogen atom or an alkyl group, or it may be an aryl group also. Okay, see, for example, if R is H, so then HCOCl. So the name of this compound is the formyl chloride. Formyl chloride. Similarly, let us consider one more example. If R is equal to CH3, R is equal to CH3, then CH3, C, double bond O, Cl. So this is acetyl chloride. So this compound is commonly called as the acetyl chloride. So if R is a phenyl group, so that is C6H by COCl. So this is called as the benzoyl chloride. Benzoyl chloride. Okay. So these compounds are called as the, that is, acid derivatives of carboxylic acids.